Good morning.
Good morning.
I'm finished grading most of the P1s. I'll finish those tonight. I've got 9 left, 8 or 9 left. I'm really impressed with the quality of them. You guys really did a good job. So give yourself a hand or a reward, or whatever you do to give yourself a reward, do that thing. Yeah, like that, yeah. Nothing illegal, because if you get caught, you'll say, well, Garfield said I should reward myself. So. All right, I need this up. And we went through this before. I'm just going to go through some reminders and then walk through some code and talk about coding technique here. Not that much example code this week because I don't think we need all that much yet. And on Friday, of course, we're going to talk about how to continue on with your work, and particularly the P2 deliverable. And I'll probably hit some of these themes again about how to go through and create. Okay, so we talked about data types and data structures. Data type is the set of values that's allowed with associated operations. And the data structure is how is it organized in memory. And for an array, it's all one contiguous block, one data value after another. And you access them using the array index, which is in square brackets. And in Java and many other programming languages, we start at 0, and we start at 0 because the way that you access an individual array is you go to the head of the array, the beginning, and then jump X spaces or I spaces to get to the element that you want. And the first element, you're already there, so you jump 0 spaces. We talked about that in Java, the array is actually an object. And since it's an object, that means that you have access to a bunch of methods. You know what? Bear with me for a second. Let's try this. That's not right. Oracle, Java, array, class. Here's the Oracle help page. Oracle is useful. They own Java, so they're going to give you the definitive definitions for these things. And they tell you here, Java util arrays, that's actually what its class is. It's in the utility section. And it's a child of the Java lang object. It turns out everything is a child of object. That's the highest object, and everything is a child of that. Even the classes that you create are a child of object. And it extends object, right, because it's a child of object. And then they have the method summary here. So in the Oracle help pages, they tell you all the methods that are available. And if you look at these methods, there's a lot. As list, I don't even know what most of these are. Binary search, binary search, binary search. In other words, you can set this up as a tree automatically and do binary searches on these things. Copy of, you can create a copy of it, and notice there's a bunch of different versions of that. You can copy just a range of values. My guess is you can also copy not just a range, but probably you can copy based on some specified Boolean test, like everything higher than a value or lower than a value. Equals is about whether these are, you have to read these, whether their values are of the two different arrays are equal to each other, that kind of thing. And then they've got, just all kinds of stuff. Right? Look at all these things you get for free. You will never need to do these with an array. ToString you may actually use if you want to print out the values of an array. ToString is a way to do that. So just be aware that these pages exist. That's really the point of this. Be aware that these pages exist and that you have access to the Oracle help pages, and that things that are objects in Oracle tend to have, in Java, tend to have a whole bunch of pre-built methods for you. that you rarely will use, but they are available. And then once they give you that shorthand, for each method, they give you a longer description. So this is a really long page. The attributes, I'm surprised I'm not seeing the attributes right off top. Maybe the only attribute is the length. Be aware that that stuff is there for you. When we get into the graphics section of the course, you will want to use the Oracle help pages a lot more. This is my prediction. That's my prediction. Okay. So remember that creating an array, you can declare an array and then you can create the array. Because it's an object, it's not created until you use the new keyword. Well, what's happening when you would declare it? Remember, you are just saying, basically, I'm going to put a little placeholder here, because someday when you create the array, I need to know where it is in memory. And that placeholder, I often call it a handle. That provides a place for the handle for the object. And in this case, the object is an array. The way we build up methods, I'll go through in the code. And typically we want to have methods called by other objects. And when do you make a method? Okay, so let's go through this process again, and we'll walk through it with the code a little bit. You're thinking about your project. Okay, I want my software to do this. In order to do that, I'm going to chunk it out into different tasks or sections of code, and those sections become your classes. And then you say, what do I need in each class to describe the class? I need these attributes. That's usually a fairly straightforward process. Now, deciding that you need a class or don't need a class, that takes practice. But once you decide, okay, this is an object. I know that this is going to be an object in my code. Deciding what the attributes are. Usually that's not too difficult. And of course you are allowed to change your mind. You're not required to get it right the first time. As you start to fill out your software, you'll remember, oh wait, I need to have this descriptive thing for this object too, therefore I'll add an attribute for it. My only recommendation with that is if you can calculate it, don't make it an attribute. So in this case, like I have an array of numbers and we can calculate the average, I would not have an attribute for the average. Who knows why?
Because it can change.
If I change the array values, then that average value is no good anymore. And you have to remember to change it. And you're human. You may not always remember to change it. Or worse yet, you leave the project, someone else comes on board, and they didn't even know that you had an average attribute, and now their values are wrong. So don't build traps for yourself. If you can calculate a value, it's okay to recalculate it over and over and over again. And again, this goes back to, in the old days, we used to really worry about how many computer cycles we were using and how much memory we were taking up. And now, memory's cheap and chips are fast. So don't build these traps for yourself. And then you start to ask, once you just have all the attributes down, you say, okay, what does this thing need to do? And one way to think about that is, if someone wanted to ask questions of this object, what kinds of questions would they ask? Or if someone needed a service provided from this object, what service would they need to provide? And so once you start answering those questions, each answer becomes a method. And that, I will not pretend, is ever easy. That's something that you often will change your mind about as you start to actually flesh out your code. Okay, so that's that. Now let's go through this code. I wonder. I'll create a module 4 here, this PC. No. I'm not sure that we have to run it, but set it up to run. By the way, there's a question on the evaluation forms at the end of the semester. Was the instructor prepared for class? And don't use today as a judge, right? No, he didn't set up the files. Let's see. There we go. And now let me get rid of these guys. All right, just so, and here, the reason I'm reopening these is so I'm editing the proper ones. Okay, let's see if these things work, by the way. They should. Unless I edited them in between semesters and didn't pay attention. Oh, there we go. And then we can run. If I run random data, it'll say, I can't find main because I didn't put main in there. But if I run random data controller, then I get some values. And so all I did is I filled it full of 13 values. Notice since it's 13 values, the first one is 0, the last one is 13. That's how the indexing works. I filled it full of random numbers, and then I asked to find the maximum value and the minimum value, and you can check and convince yourself that it really did that correctly. What did this code look like, though? Well, I have a random data class. And why did I create a random data class? It's a absolutely artificial example of using an array and using methods. So I build an array, and then I build and then I added some methods to do stuff with the array. I'm treating the array, lost my cursor there. I'm treating the array as an attribute of this class. Why am I treating the array as an attribute of this class instead of making it a variable inside of these methods?
So you can work with it outside of those methods.
Exactly. So every method has access to the attributes in the class. And since I want to do something with this array in every method, I'll make it an attribute so every method has access to it. And you can think of it like a global data variable inside the class, just inside the class. Remember, we're encapsulating our data. That's the #1 reason for the OO paradigm. So inside the class, they act like global variables. Outside the class, nobody gets to see them unless we allow it. Then you start to say, okay, what methods do I need? Well, first of all, I need a method that fills up the data inside, right? That fills this thing with meaningful data. Now, I declared the array here. I did not make the array. And again, why would I do that? I would do that because I don't know how big you want the array to be. If I want to make this generic, then I want other users to be able to use it. Another way to frame it is, I want to make this generic because here today I might say, you know what, I need my array to be 100 elements big, and I would size it to be 100 elements big. And then 2 weeks down the road, I realize, oh wait, sometimes it needs to be 200 elements big or 1,000 elements big. So you make these things as generic as possible. So I'm making it where I declare it, but I don't make it yet because I don't know how big it is yet. And I don't know how people want to put the data in. So I'm going to first build something called initialize data. Now, here's how I build that. Oh, what have I done? That's what I want. That's how I build it. So when I first build it, all I do is I build the signature here, basically. Okay, it's public, it's void, it doesn't return anything. All it does is initialize the data, public void, initialize data, and then I need someone to tell me the size that they want. So I know that much. And then when I first build it, That's all I do, is I print it out that somebody called me. Why do I do that? Well, in order to have a working framework for your software where you can test things, you probably need most or all of your pieces of software to work. So you're not going to write all your software at one time. You're going to write your software one method at a time, one class at a time. But if you just built one class in your software, it needs the other classes to work with it, right? So you can't test it. So what I tend to do is I'll take all the classes that I think I'm going to have at the end. I build them all like this, what I'm calling empty methods, do nothing methods, dummy methods. Now I can build things, and if anybody ever needs to call my random data, initialized data method, they can. Even though I'm not building this yet, maybe I'm building something else somewhere else in my code, and I need to test it, and I need it to be able to call that initialized data method. I don't care about the results. I can build and test that other piece of code. So what I'm asking you for in your P4 deliverable is to have all of your code there, most of which will be empty. Because at P4 you're delivering some functionality. But the idea is you have all functioning code here. By the way, let's do something here. I'm going to save that. Hopefully I won't regret this decision. I'm going to save that, and then I'm going to compile it, and then I'm going to run this random data controller, and it says, wow, random data class initialization data method called. That's what I put in there, right? I said, hey, initialize data called. And then it has this funny exception in thread main, null pointer exception. Random data Java 29, random data controller Java 21. So let's see, random data Java controller 21, that's this line of code where I say print the data. And under here on line 29, it says for I equals 0, I less than data dot length, I plus plus. And I got a null pointer exception. Why is that? First of all, what does that mean, null pointer exception? Are you guys furiously Googling? A null pointer exception.
Oh, I guess.
Yeah, go ahead, Jared.
Wait. I guess I'll do it. Just waiting for someone else. Null pointer exception is just when you're trying to access either an object or variable before it's actually been made.
Right. So we didn't make the integer array yet, right? I've declared it up here, but I don't have the new keyword, so it hasn't been made yet. So basically what null pointer exception is telling you, you're trying to access an object that has not been made yet. And remember, an array is an object. So I didn't make it yet. How would I fix that? When I'm doing that dummy data stuff, instead of actually doing this, it would say, I would just have it print data. I would just have it print out somebody called me like I did on the previous one. Why did it do it on line 29? Because that's the first time we try to access the actual data object. Data.length. That's the length is the attribute of an array object. So that's what's happening there. All right, now let me see if I can back my way back into where I was before where this thing worked. Save it, recompile it. Yay, now it works again. Okay. This is what I'm saying to you guys. When you get sample code from me, break it, fix it. So I'm asking myself, okay, let's see, what methods do I have here? I have initialize data, I have print data, I have calculate maximum. I guess I have calculate minimum. I forgot to include that in the list. You can add more, calculate average, sort. We need setters and getters, right? If we do setters and getters, should we get the whole array or should we just get a specific element in the array? There's no right answer. It depends on what your It depends on what your application is, but you could create individual methods for that. By the way, this way of doing filling this up with random data, that's a fairly common form. I use the math.round function. I use math.random, which gives you from 0 to 1 evenly distributed. It's not a bell curve, it's evenly distributed. Then I multiply it by 10,000, purely random number. And then I do math.round because it's an integer array, and math.random gives you a double, so I need to do something to fix that. So I do math.round, which is supposed to round it to the nearest integer value. Unfortunately, Java still isn't 100% certain that it's an integer yet. So I put this in front of it, int. This is called casting. It's where you want to really drive home to the compiler what data type you're dealing with. And as long as the compiler can figure out how to turn that double into an integer value, then it will do it based on that casting. So the way we deal with arrays, and again, this is how your for loop is going to look almost all the time, because almost all the time in a for loop, you're walking through an array. So for those arrays, int I equals 0, that means I'm going to go to the first element, I is less than data.length. That's the usefulness of the length. Notice it doesn't matter how big the array is. As soon as I create it, that data.length will be set within the object for me, I++, and then I just take the ith element and fill it full of random data. And then print data, which is probably not something you're going to have except maybe for testing purposes, because who wants to print out 1 million data items? Print data, same trick, except now I just print it out. That was there just for demonstration purposes. Calculate max, calculate average, calculate min, sort the data. Notice I have these as empty methods right now. So the reason that I'm able to refer to inside these methods, all I have to do is refer to data because I made it an attribute. And I gave it the highly descriptive name data. So because that's an attribute, that's why I'm able to refer to it in the methods. And that's why you want to make these things attributes. If you know that more than one method needs access to this stuff, if you know that you need to keep it more or less permanent in order to deal with it over and over again, it's describing the state of the object, then make it an attribute. Now, if it's something that can be calculated, like here, I have max element. I don't have an attribute for max element. And again, that's because that's a trap. I make an array, I make the array, I find the max element, I store the max element in an attribute value, then I make a brand new array and my max element's no good anymore. I can always recalculate it. I've got a method for that. I don't have setters and getters here for this particular example because that data array, I probably should have added set and get for specific array elements. So this is just a typical class or object. It does not have main in it. You can't run it by itself. And then you would have something else, another class that runs it. So in order to do that, by the way, I probably should have made that an attribute too, but I did, of this class. I have my random data controller. Its job is to control the random data object. You're going to have in your, when we start laying out how projects work, I'm going to recommend that you have all of your objects that do whatever the project is that you're going to do, and then you have one file that's the controller. It makes objects of those classes. So you've got the sheepdog game. I would have one class that's a game controller. That class is the one that builds the terrain, builds the 3 sheep, builds the dog, and then serves as an interface between the GUI and those classes. So it's normal, again, in the object-oriented world for you to have collections of objects. Your code is not just one code like you had before, or it's not even like in C where you brought in other pieces of software using header files. It's collections of objects. It's kind of hard to say, well, wait a minute, what's the code here? Well, it's this collection of objects. You can have main in more than one object, and you would do that primarily for testing purposes or for development purposes. So that's his job. The whole point of this is just to show you how two objects work together, how one object builds and controls another one. And I think next week we talk more about this. So anyway, the first thing I do inside main is I build myself, and I actually build it. I actually build an object of that class, and you know it because the keyword is there. What's its data type? Random data. That's the name of the class. Remember randomdata.java, randomdata.class files? The classes you create are called user-defined data types for a reason. They really are data types. And so that's why that data type goes there. Random data, my data equals new random data. Now, I'll reinforce this next week, but what's really happening? My data is the name of that object. That's the variable that we're using for that object. What does my data really contain? Kind of like with the arrays, it really just contains a handle to the object. In terms of memory structure, it really just contains a reference to, okay, you told me to go build, right? New random data, you told me to go build a random data object. Okay, I did, it's in memory now. Where is it? That's what gets stored in my data. And then we say, okay, my data dot attributes and methods. I can't refer to the, no, I don't think I made that private, did I? Gosh, let's fix that. There. I can't refer to the data directly because it's private, which is the way that you should build your programs. And so instead, I refer to it by the methods, the public methods. So remember, you want to protect your data, make your data private, but think of your class as a service provider to other objects or to other entities, and therefore they need to have public ways of accessing those services. And this trick of making an object and then initializing it, I'm a big fan of it. I think if you think about it, even if you have an object that's moderately sophisticated, you're going to have a number of attribute values, and you probably don't want to hard code them. You probably want to have an initialize object kind of method. Now it may be hard coded, that's fine, but what you're doing is you're taking the details. Again, take the details out of the main line of code that people are reading. So here I just I had that method in the random data class called initialize data, and I just arbitrarily made it 14 elements big. You know, we can make it 35. There, it's 35 elements big. Let's do this. 10. What do you think will happen? I hope I get an error. Negative array size exception. Play with code. Ask yourself questions like that. So, you know, a lot of times I do get students asking questions. Hey, can I do this? And my answer often is, I don't know, code it. You know, code it up and try it and see what happens. All right, so I recommend having some kind of an initialization phase, and you'll see this theme as we go through the course and I give you more examples. I'm going to have, okay, here's where I construct stuff, and then here's where I initialize it all. The other thing having an initialization like that is, this is just stupid random data. A lot of you are building software where I think you would benefit from having your initialization occur via file input. So some of you are doing like dungeon crawler games. Some of you are doing games where you're going to save configurations or where you want to have specific configurations for different levels of the game. I say, build a file format, be careful about your file format, and then you can pull in that data from the file. And the reason is, if you need to change it, you change that external file. You don't have to go recompiling your code. And then I printed it out for absolutely no reason other than it's a sample code. And then calculate max, calculate min. And the idea here is By doing all the work in the methods, you can read through this main code and see what's going on. And again, I like to, as much as possible, I try not to do any work at all in main. It's just method call, method call, method call, method call. You know, load game, play game. Oh, okay, I know what's going on there. If you do that, it helps your readability. If people want to know the details of what happened, then they go down to the next layer. And even then, you can do that same trick again. If you've got a method that's fairly sophisticated and it has to do 8 different things, maybe it reads like 8 different method calls so that people can just read through it. Ultimately, if they need to know the details, they'll keep driving down those methods until they get to the actual work. But by then, the amount of work they're looking at is so small, it is in theory harder to get lost in the code. Now, what's happening really is I'm kind of pushing off where did I get lost in the code. If you do all your work in one big long piece of code, the way that C programs tend to be written, the way that MATLAB programs tend to be written, then you get lost in the code right away. Here you can get lost because you're going up and down this chain of methods, and it's like, where the heck are they actually doing the work? So when you're new to it, sometimes, at least my experience was, that was a little confusing to me, because it's like, well, I know they're doing something, but they just keep calling methods. Eventually, I need to see some work being done. Okay, let me do this average. Calculate maximum. Calculate average. Right now, it's a dummy method, right? Now, how do I actually calculate the average of a set of numbers? What's the true, forget code, what does math say I do? What does your statistics class say?
Add them all together, divide by the number.
Right, right. Add them all together, divide by the number. So I need to do 2 things. I need to add them all together and divide by the number. Now, that means that I can do this. Let's do it real time. Hopefully this won't take long. Let's see. Whoops. It returns a double. And so we're going to say int sum, whoops. Add them all together. And then we're going to divide by the number. And so then I get just going to copy. Settle down. Here's my for loop. This is dangerous, because if you don't okay, but I don't need that. I just need sum equals sum plus data I, right? Is that right? That's that. That's that. Got one too many brackets. There we go. And then I need to return a value. And then I'll return sum divided by data.length. And again, I'm taking advantage of the fact that we know what the length is. That look good to you guys? I'll give you a minute to look at it. Okay, now I'm using, for those of you that have used Java before, I am using a rather verbose form of the addition. I tend to stay that way. Okay. And then over here, we can add in, let's try to call the, and it's going to be, two hardest things in the world to do: watch someone play chess and watch someone code. Okay. Let's see if I screwed it up. I very likely screwed it up. Yay, average value -0. Okay. Something's wrong. Oh, it's because I never saved this one. There we go. That's what I had before. Yeah, compiled, that's good. Okay, average value is that. All right, now. Notice how many lines of code I wrote. What did I write? 1, 2, 3, 4 lines of code here and 1 line of code there. That's about how many lines of code I trust before I'll save and compile if I can get away with it. So number one, when you're writing your code, don't start writing 20, 30, 40 lines of code and then compile it and run if you can help it. My recommendation is compile and run as often as possible. You do one little bitty thing, compile and run. It will help your debugging. I've had people that, you know, they write, they're doing, you know, working in 4 different classes. They try to do a whole bunch of work in each one, and then they compile and run, and they just get a mess. And it's not like you got a lot of error messages. You got a lot that are all tangled up with each other. So it's hard to figure out which one was the real root cause of this thing. So that's the first thing. My advice to you, a few lines of code, compile and run. Especially, you know, you saw how easy it is here. It's just as easy on Eclipse. You click that little run button. The other thing, though, is look what I did. I did 2 things, right? We said calculate average was 2 things. It was sum and then divide by the number. And if it's 2 things, I want my methods to do 1 thing. So I'm going to get rid of that. And I'm going to write a method called
Does the array object not have a sum method?
It absolutely does, and I'm avoiding that for demonstration purposes. I should say I haven't used it, but I would be absolutely flabbergasted if it didn't. Let's put it that way. And so now what I'm going to do is whoops, that. Okay. The resizing was not intentional. So the idea, oh man, I'm a bad speller. Calculate. So now my calculate average, I used calculate sum, and that seems like, oh man, that seems like a lot of extra work. Why did you create that extra method? A couple of reasons. Number one, if you break your tasks down into, okay, these are the smallest tasks that really can't be broken down anymore, then they become like utilities or building blocks. And then the other methods that you need to build can just use those. I use, you know, for here I just made calculate sum, and then I made calculate sum a different method. If I ever need to create another method that for whatever reason needs to get the sum of all of these things, then I've already got that built, and I can take advantage of it. So sometimes you'll find that you want to build 5 different methods, and 3 of them are doing a lot, you know, they're doing all the same prep work basically. Well, that prep work should become another smaller method. And that way, maybe you'll need to come back later and say, oh shoot, there's a 6th method I need to do, but you've already got the prep work or the, you know, the foundational work. You've got the bricks handy to build the building. And was that you, Jared, about doesn't it have a calculate sum? Absolutely. Now, by the way, calculate sum is an integer. This means we're going to have an integer divided by an integer. And I suspect, my suspicion, the way Java handles types is I suspect that that's going to give us a slight problem. So let's see if we can, oh man, I'm saving these things. It's too small. All right, so let's see. I may get errors. That's fine. I'm, you know, I am the king of typos. And save that, save that. And oh, I know what I want to do. Okay. I want to get rid of 10. 10 is a deceptive number. Let's use a prime number. All right, so let's see, first of all, does it compile? Compiles. And then if we run compare, we get, okay, so we had 13 and the average was 39.77.0. And if I run it again, the average is 0.0. And if I run it again, well, what is the likelihood that if I have 13 elements that the sum of that was divisible by 13 3 times in a row? It's possible, right? It's possible, but it's not very likely. So what's happening? And some of you guys, I think, how does C do this, guys? If I take an integer value, and I divide it by an integer value, then what happens in C? Does it truncate and give you an integer? Any of you guys from Behe's 223 class? How about MATLAB? Does it truncate to an integer?
We don't do data types in MATLAB.
Oh, that's right. But you do have the you do use things as integers. Yeah. So.
Yeah.
I think MATLAB would ignore that then. Yeah.
I think Java just chops off everything.
Java just exactly, and that's what's happening here. Is we're getting a truncation. Now, if that's what you want, that's fine. If you want that, that's fine. That you could create that as a public int calculate average. As long as you're aware of it.
It doesn't throw an error, even though that you're returning an integer, even though you classified it as a double.
No, because I'm actually returning a double, and if you look, it's framed as a double. It's got the .0 in it.
So it just automatically classes
It just,
it as
right.
double.
It truncated it though, and it cut off everything after the decimal point, but then it returned it as a double. Therefore, it's going to give you a double. If you go through and let's turn that to an int. And I think we might get possible lossy conversion error. Let's see. See, now it's an int. It doesn't have the decimal sign .0. The reason the period is there is because I put it in the print statement. So if you truly needed the average, what are we going to do here? Oh, let's see. I honestly can't remember. Let's find out. If I cast it as a double ahead of time, there we go. That looks more realistic. Okay, so that's that kind of weirdness with data types. That's the kind of thing that, you should, you have your textbook, you have W3 schools, you have tutorials point, you have myself and Dean, those kinds of things. Just be aware of, what we really mean when we're talking about these data types. Different programming languages will handle them differently. And you need to know for each programming language you enter, what does it do in this situation? Usually, like in this case where it was magically returning integer values all the time, usually that's not a problem. But sometimes you're doing things where you're going to return a value that is between 0 and 1, and it keeps coming back 0. That's confusing. That's the kind of thing that's happening. These are the small details that it's hard to get into in a class. That's my recommendation. Is that's why you have the textbook. That's why you have online tools, is to find out how this stuff is working that way. What I want to give you is a lot of examples and this process of thinking in the object-oriented way and then composing code in an object-oriented, rational fashion. The agile, in this case, agile Scrum type fashion. Okay, so the big takeaways here are: create these methods that do little tiny jobs. If you have a method that does 2 jobs, maybe break it up into 2 methods. And methods, remember, have access to all the attributes in the class, and they have access to other methods in the class. So it's not uncommon to create a method that calls other methods in the class. Something else along those lines. Oh, you have access to the attributes, but remember, you do have to create an object of that class first. Inside of this class here, inside the random data, you say, well, wait a minute. No one created an object of the class random data. And yes, they did over here. This one did it. The controller did it. And that's usually how that goes. The only reason you might want to have your own main inside a random data that creates an object of itself would be for test cases. And that, I will allow, gets confusing sometimes when you're first doing this. I mean, that is a, you know, in the object-oriented paradigm, it's a different way of thinking about software. And so there's a different set of rules that you have to remember. And the basic rule is you cannot access anything and anything that's non-static until you create an object of that class. Well, that's normally done by another object. You can do it within the same object. Now, if I was really running test data, I probably still wouldn't do it inside main. I would have a, let's see here. Maybe I'd do something like this. Well, I can't type. And then down here, I would have my methods for testing, which I would again construct as one method that says test everything, and then that just calls the individual test cases. And what can you do in your individual test cases? You can set up this array of data to be anything you want and then test it. So for example, if I wanted to test the average, I probably would fill the array with all zeros and see if that was if that came back as an average of 0 without crashing. I'd probably fill it with all of the same number, like 100, and make sure it came back 100. And then I would fill it with a variety of numbers that I specified, not just random numbers anymore, numbers that I specified. And so I know ahead of time what to expect back. But that would be one method called by this test method. Again, the theme is each method should do one job. I'm bringing up these test methods only because as you go through your project, you know, I'm going to ask you, require of you to do testing, and you need to, I highly recommend that you build it into your code. I'll have students that do it, you know, by the user at the console, and you don't have to do that. You can build methods in your code where you control what the attribute values are, and you control, and you have an expectation of results. Okay, that's plenty for today. Are there questions before we go? My recommendation is to write silly code like this and develop a coding style for yourself. You're getting practice with the homework, so that's good. But you know, you can write short little pieces of code like this in not much time, and then you can ask yourself questions: what happens if? What happens if? What happens if? Play with it, break it. See if you can understand why it broke and how to fix it. Okay. This video will be up hopefully by the end of the day, definitely by tomorrow. Bye, guys.